Hello, this is Brother Kermer from the Math Department, and these videos will be covering the lesson dealing with inference for one proportion. And so here's the outline for inference for one proportion. First I'll be discussing confidence intervals, and then I'll wrap it up with hypothesis testing. Within each of these items I'll be covering how to do descriptive statistics for each, as well as, or what descriptive statistics you'll be using, as well as what type of requirements that you will be checking. Okay? So first of all, let's review the difference between a parameter and a statistic. So a parameter is a measure of a population that's typically unknown, we'd like to estimate. Okay, so back in Unit 2, the parameter of interest was typically mu, and now it is p, or our population proportion. U is our population mean, and p is our population proportion. A statistic is a measure from a sample. The statistic is used to measure the unknown parameter. So for instance, back in Unit 2 we have x bar, or our sample mean. And now we have p hat, which is our sample proportion. So x bar, or our sample mean, estimates mu, or our population mean. And p hat, which is our sample proportion, is used to estimate p, which is our population proportion. Okay? So this unit will be focusing on how the sample proportion can estimate p. However, now p hat, we'll discover later, is a form of a point estimate. But what we're going to do, instead of a point estimate, we're going to get into confidence intervals. But before I get into that, I want to discuss the distribution of a sample proportion. So sampling distributions, or distribution of a sample proportion, has many sample proportions for many samples. However, due to time and money, one cannot take multiple samples or sample the whole population, so we infer based on one sample. So the statistic from the sample can be anywhere in the sampling distribution, or the distribution of a sample proportion. So if this is the distribution of a sample proportion, we can get a sample proportion here, or here, or here, or anywhere within this distribution of the sample proportion. Okay? So what we're going to be doing is that we're going to be covering a confidence interval. We're going to get an estimate of our population proportion by creating a confidence interval. And we've done this before with a population mean, but now we're going to do this with a population proportion. So as a review here, a confidence interval for an unknown parameter consists of an interval of numbers. Okay? It deals with a point estimate, plus or minus a margin of error. Okay? Point estimate back in Unit 2 was our sample mean, okay, or can be, or was an example. That's an example where we have a sample mean. And we take that sample mean plus or minus a margin of error to get our confidence interval for the true population mean. Now for this unit, we're going to take a sample proportion and subtract a margin of error to get a confidence interval for the true population proportion. So an example of this is, say, for instance, we wanted to see what percentage of people will be voting for the President Obama, before an election. And so say, for instance, we get a result where the point estimate is, say, 51%, and we have a margin of error of, say, 3%. So if we add and subtract 3% from our point estimate of 52, we would say that we would be X% confident that the percentage of people voting for Barack Obama would be between 49 and 55%. Okay. So how do we calculate this? Well, we have a confidence interval where it's what's called the 1 minus alpha times 100%, and in parentheses +4 confidence interval. Now we're using the +4 confidence interval because it is, regardless of what sample size you have, it's more accurate, but it's particularly dealing with those with small sample size. If we have a +4 estimator, we are more accurate rather than not having a +4 estimator. So basically the confidence interval is P tilde, and this is how we pronounce it, P tilde, plus or minus a margin of error, where we use a critical value, and these critical values are the same critical values that we used before for the 90, 95, and 99% confidence intervals. And then we times it by, in the square root, we times it by P tilde times 1 minus P tilde divided by n minus 4. Okay? And P tilde is basically x plus 2 divided by n plus 4. X is the number of people that meet a certain characteristic. For instance, if we're trying to see how many people would vote for Barack Obama, X from our sample represents the number of people that would vote for Barack Obama. Okay? Z is our critical value, as I mentioned before, n is our sample size, and everything to the right of the plus or minus sign is the margin of error. Okay? So here's an example of this, sir. So before the election, this is going back to 2008, before the election you conduct a survey of Californians to see if they are in favor of Proposition 8. You take a simple random sample of 1,000 Californians. Out of your sample, 540 in your sample say they are in favor of the ballot measure. You would like to get a 95% confidence interval of those who are in favor of the proposition. Okay? So step one, what I want you to do is get an estimate of the sample proportion of p tilde for those who are in favor. Okay? So basically what we do is that we're going to get p tilde, we take x plus 2 divided by n plus 4. X in this case is the 540 in our sample who say they're in favor of Proposition 8. So we add 2 to that, so we get 542 divided by our sample size, which is 1,000 plus 4, so we get 1,004. So when we take 542 divided by 1,004, we get 0.540. Okay, so to check the requirements, we'll get to that a little bit later, but basically the requirement is, so long as our sample size is greater than 5, the requirement is met. And that's the beauty of using the plus 4 estimator, is that we can get a small sample size, and it would be sufficient for us to have a good confidence interval for the estimate for our sample, for our population proportion. So to construct and interpret a 95% confidence interval for the true proportion of those in favor of the proposition. So here's the formula for it. So what we do is we take p tilde, which is 0.540, plus or minus, since we're doing a 95% confidence interval, we use a critical value of 1.96, times the square root of, and then we take p tilde, which is 0.540, times 1 minus p tilde, which is 1 minus 0.540, divided by n plus 4, which is 1,004, 1,000 plus 4. And then when we add and subtract this from our point estimate, we get our confidence interval. And so we say that we are 95% confident that the true proportion of Californians in favor of Prop 8 is between 0.509 and 0.571. Okay? So what happens to the confidence interval as the level of confidence in the sample size changes? So this is kind of a review from what we did back in Unit 2. But basically, as our confidence, or our level of confidence increases, the width of our confidence interval also increases. That's because if we increase our level of confidence, this number goes up. And so therefore, the margin of error, or our confidence, the width of our confidence interval goes up. But if our sample size increases, the interval, or the width of our interval, decreases. Because n is in our denominator here, and since our denominator in our margin of error, it's going to make the margin of error smaller. And so in turn, we're going to have the width of our confidence interval be smaller as well too. Okay? So what I'm going to do is that I'm going to stop the video, and I'm going to continue with dealing with confidence intervals in the next example.